Welcome back, learners. As you know, we are studying chapter 5th, periodic classification of elements. Look, in this chapter previously we get introduced to the modern periodic table. Now we will study the trends in modern periodic table. In this table, students, some properties show a regular trend when we move along a period from left to right or in a group from top to bottom. So these properties will be discussed by us. First of all, we are going to study the characteristics of periods. All the properties will be discussed by us and we will see how they change when we move from left to right. First of all, let's start with valence electron, also known as outermost electrons. So students, on moving left to right in a period, the number of valence electron in element increases from 1 to 8. We will understand it by taking one example. Students, we have taken elements of third period. Okay, third period is having first element as sodium, then magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and lastly argon. So their atomic number are from 11 to 18 respectively. We all are aware of electronic configuration. So for sodium it will be 281. K shell must have 2 electron, L shell at most 8 electron, and then the remaining will be transferred to M shell having 1 electron. Okay, now have a look on the next one, magnesium. It has configuration 282, then 283. You can see the last number has been shown in pink. So that is the outermost shell electrons. They are known as valence electrons. Now we can conclude. First element is having 1 valence electron, then 2, 3, 4 and up to 8. That's why we are saying that the number of valence electron while moving from left to right increases from 1 to 8. So this was the first property. Let's discuss next. Here you can see it's valency. So first of all, we will understand what is valency. Students, the combining capacity of an element is known as valency. Look, every element want to acquire a noble gas configuration. For that element will either lose electron or gain electron. So the number of electrons that an element will exchange in order to get stable is known as its valency. So when we move from left to right, first of all the valency increases from 1 to 4 and then decreases to 0. Let's find out why so. Look, we know that sodium is having valency 1 just because it's having valence electron 1. So it will lose 1 electron in order to get noble gas configuration. Then magnesium is having number of valence electron 2. That's why its valency is 2. It will also lose these 2 electron. Aluminium is having 3 electron in the outermost shell. That's why its valency is also 3. Let's talk about silicon. It's having configuration 284. Obviously, its valency is 4. Now phosphorus. Students, its configuration is 285. So if someone is having 5 electron in the valence shell, it will need 3 extra electron in order to make octet. That's why it's having valency 3. Then sulfur, which is having atomic number 16 and configuration 286, needed 2 more electron. Then chlorine, 17 electron in total. So the configuration is 287 and it need 1 more electron. That's why valency is 1. Lastly, let's talk about your noble gas argon. Argon is having completely filled shell. Okay, configuration is 288. That's why the valency is 0. So you have seen the trend. First it will increase up to 4, then decrease up to 0. Let's talk about the next property that's on your screen. It's size of atom, atomic size. Students, the distance from nucleus to the outermost shell, this is known as your atomic size or size of an atom. So first of all, let's understand what's the trend. While moving from left to right in a period, along a periodic table, the size of atom decreases. Okay, this is sodium and this is your chlorine. From sodium till chlorine, the size of atom will decrease. You can see here The atomic radius in picometer has been given 186, then 160, 143, 118, 110, 104, lastly 99. Why so? Actually, when we move from left to right, the number of electron they are added in same cell. Okay. Sodium is having configuration, let me write it here. It's having configuration 281. Magnesium is having 282. Okay. Then your aluminium 283. Again silicon 284. What do you see? Look, this is K shell, this is L shell, this is M shell. The number of electron are adding in M shell, and along with that the number of proton is also increasing. So this result in increase in effective nuclear charge. The nucleus attracts the outermost electron more efficiently. That's why the size decreases. Okay, this is the reason. You can say the number of electron are they are being filled in same shell, and because of increase in nuclear charge the size is decreasing. So we have seen the trend as well as the reason. Let's move to the next topic. Here, metallic character. So students, again we have selected the third period to understand it. While moving from left to right, the metallic character decreases. Okay, we can even say the non-metallic character increases. Let's understand why so. Sodium is highly reactive metal. Magnesium is reactive metal, but it is lesser reactive when we compare it with sodium. Then aluminium is also metal, but not so reactive. So this is the decreasing order of their reactivity. Then silicon, it's a metalloid. Students, metalloid is someone which is having common property with metals and non-metals. Now, phosphorus is a non-metal. Sulfur is again a non-metal, and chlorine is most reactive non-metal among these three. Okay, so in this manner we can conclude that when we move from left to right at that time, metallic character decreases. You can even say your non-metallic character increases. So this was the trend and property. Now let's move to the next one. Here on your screen, this is chemical reactivity. As the name itself suggests, the tendency to react. Okay, that is chemical reactivity. Students, recently we have discussed the increasing order of non-metallic character, or even you can say decreasing order of metallic character. Now that will help you. Look, as I told you, sodium is very reactive metal. Okay, then magnesium is lesser reactive, and among these aluminium is the least one when we talk about metals. Then this silicon is a metalloid. Okay, again non-metal, sulfur non-metal, and chlorine very reactive non-metal. So what's the order? Firstly, chemical reactivity decreases because we are saying that we are having a highly reactive metal at first, then we are going till metalloid. That's why chemical reactivity is decreasing. Later on, after the metalloid, you are seeing non-metals, and slowly their chemical reactivity is increasing. So this is the order. Let's discuss the next one. Here on your screen, it's nature of oxides. Students, you must know that we have studied, it has been discussed in chapter metals and non-metals as well. Oxides of metals are mostly basic in nature, while oxides of non-metals are acidic in nature. Okay, though some metals, including metalloids, they are having amphoteric oxides. When I say amphoteric oxide, it means that those oxides which are having common property of both acidic oxides and basic oxide. It means that they can react with acid and also with base. When they are reacting with acid, they are behaving as a base, and when they react with a base, at that time they behave as a acid. So this is the way. Okay. Now, when we move from left to right in a period, the basic nature of oxide decreases and the acidic nature increases. Why so? Let's have a look. Sodium is very reactive metal, so its oxide going to be highly basic. Okay. Then have a look on aluminium and silicon. They form amphoteric oxide, and after that phosphorus, sulfur and chlorine will form acidic oxides. Among them, chlorine's oxide is highly acidic. So that's why we can say basic nature of oxide is decreasing when we move from left to right, and when we move from left to right we can say acidic nature of oxide is increasing. So this was it, students. Now we have discussed all the trends which were possible in a period from left to right. In the next video we will study all these properties along a group. So that's all for today. Keep learning, keep asking.